Hello students, welcome to our channel. This is KP. I am teaching the arithmetic, reasoning and mathematics statistics concepts for competitive exams and many more other examinations like CAT, MAT and ICET. So please watch my videos, like and share to your friends. Now I am going to deal the time and distance topic in arithmetic. So this is the part 2 video, and for previous video I am giving the link in description. Please watch the video if you need. Thank you, and I am going to start the video. In this video I am going to discuss the problems in time and distance by using the relation between time and speed, also the distance. So let us see the first problem. A person starting from his house covers a distance at 15 kilometers hour and returns to the starting place at 10 kilometers per hour. His average speed during whole journey. So the total journey is taken from his house to particular destination. So for going and returning, the distance is the same. So in this case, we use a shortcut formula. So let it be equal to the distance from house and to house treated as d. Then the starting speed is 15 kilometers per hour and returning speed is 10 kilometers per hour. Now the average speed for total journey is s equal to s1 s2 by s1 plus s2. So here the s1 is 2 into 15 into 10 by 15 plus 10. So this is equal to 2 into 15 into 10 by 25. So 5 5s are, 5 3s are, 5 1s are, 5 2s are 10. So 2 3s are 6, 6 2s are 12. So the average speed of the entire journey is 12 kilometers per hour. In this way you can easily solve the problem when you have the distance are equal for going and coming. Here we are discussing the relation between time, distance and speed. So let us see the comparing of ratio of time with others. If the ratio of time is x is to y, then the ratio of speed will be in the opposite, that is y is to x. But the ratio of distance is same as the time as x is to y. In case of ratio of speed is considered as a is to b, then the ratio of the ratio of speed is a is to b, then the ratio of time will be reversed as b is to a. So, but the ratio of distance is same as ratio of speed. That's why the ratio between time and speed is inversely proportional, and for the distance it is directly proportional to the time and also the speed. So the ratio of distance not changes, it is same as the ratio of time in case of time and the ratio of speed in case of speed. So these are the relations that you have to be in mind to solve the problems very easily. Let us see the first problem. The speeds of A and B are in the ratio 3 to 4. A takes 20 minutes more than B to reach the destination. In what time A reach the destination? So here the ratio of speeds are given as 3 to 4. So for A and B, the ratio of speeds are 3 to 4. Then the ratio of time ratio will be the opposite. So that is 4 is to 3. That's why it will be 4x is to 3x. Now we see the difference between the times A and B. So what is A and B? 4x minus 3x, that is x. The time is difference between the times are x in terms of ratio. So but given it as 20 minutes that A reaches the destination 20 minutes later. That means the x value will be 20 minutes. So here x equal to 20 minutes. Because these two are same. It is in terms of ratio and it is in terms of time. So now the time taken by A is 4x, that is 4 into 20, which is 80 minutes. And we can also say it as in terms of hours as 1 hour as 60 minutes and 20 minutes. 1 hour, 20 minutes, because hour is 60 minutes. In this way, you can solve very easily the problem and can be determine the answer in very short period of time. Now we see the next problem. A is twice as fast as B and B is thrice as fast as C. So the journey covered by C in 42 minutes will be covered by A in what time? So here the C is traveled over 42 minutes. The same distance A is traveled in how much of time? This has to be determined here. So now the speeds ratio are given here. Let us discuss that. The speed of A is twice as B. That is A equal to 2 times of B. This implies A by B equal to 2 by 1. This means A equal to 2 and B equal to 1. So the speeds ratio is 2 is to 1. Then the time ratio will be what becomes 1 is to 2. So that's why reverse 1 is to 2 na. That's why the times ratio of times A and B is 1x and 2x. Let it be. So now discuss the B and C. So the speed of B is thrice of C. That means here B means B equal to 3C. So that's why that means B by C equal to 3 by 1. So B equal to 3, C equal to 1. The value of ratios for speeds. That's why the speeds of B is to C is 3 is to 1. Then the time ratio will be the reverse 1 is to 3. That's why the times of B and C will be denoted by 1 by and 3 by. But here we have the time for C is 42 minutes. That means this 3 by equal to 40. This 3y equal to 42. That means y equal to 42 by 3. So 3 ones are 3, 12 is there, 3, 4. 14. So 14 minutes. That's the time taken by B is 12 minutes to cover the same distance traveled by, 14 minutes traveled by the C. Now we consider the ratio of times AB. It is 1x is to 2x. Here we have 14 minutes as 2x. So the time for A is 1x, that is 14 by 2, so which is 2 ones are 2 sevens are. So the time that A taken to cover the same distance covered by C is 7 minutes is your answer. We see the next problem in this session. By walking 3 by 4 of his usual speed, a man reaches his office 20 minutes later than usual. His usual time is. So here 3 by 4 of usual time, usual speed equal to late speed. So that's why 3 by 4 equal to late by usual. So you can now get an idea that late speed is 3x and usual speed is 4x. So the ratio of speeds is 4 is to 3, usual to late. So with this, the time of usual and late will be opposite of this. That means here 3 is to 4, let it be 3x is to 4x. So the times are for usual 3x and for late 4x. So the difference between these two times is 4x minus 3x. That is late time is 4x and usual time is 3x 1x. According to the problem, the late is 20 minutes. So here according to ratio 1x is late and time is 20. So 1x equal to 20 minutes. Here usual speed is 3x. So the usual time to reach the destination is 3x, that is 3 into 20, that equal to 60 minutes. So your answer is 60 minutes. Last problem in this session is the ratio between the speeds of two trains is 7 is to 8. If the second train runs 400 kilometers in 5 hours, the speed of the first train is. So here the ratio of two trains are given. So the ratio is 7x is to 8x. That is first one is 7x and second one is 8x. 7x to 8. So and here the given information is second train travels 800 kilometers and the time taken for this for the distance is 5 hours. So we can find the speed of the second train speed is s equal to distance by time. So we have it is 400 distance and 5. 5 ones are 5 eights are 40 and 0 remains 0. So that is 80 kilometers per hour. So as the measures are given in kilometers and hours. So the ratio of second speed train is 8x. So this 80 kilometers equal to this 8x. That's why 8x equal to 80 and the x will be 80 by 8 equal to 10 kilometers per. Now we find the first train speed, it is 7x. So 7x equal to 7 into 10 which equal to 70 kilometers per. So this is your answer. Thank you. We will meet in the next video.